Now we are on page 4 of our semester review. Let's start with number 25. If the perimeter ratio of two similar triangles is 3 to 5, then the area ratio would be 3 to 5 squared. Squaring the top, I get 9. Squaring the bottom, I get 25. So the area ratio would be 9 to 25. 26. Choose the sets that are possible side lengths of a right triangle. Well, if they're a right triangle, they would work in the Pythagorean theorem. 1 squared plus 1 squared does not equal 2 squared. 1 squared plus 1 squared equals the square root of 2 squared. I get 1 plus 1 equals 2. So B works. Let's take a look at this one. 3 squared plus 4 squared equals 7 squared. I get 9 plus 16 equals 49. That one doesn't work. How about 3 squared plus 4 squared equals 5 squared? Yep, this is one of the more common Pythagorean triples. Number 27. For each set of numbers, determine whether the set of numbers represents the lengths of the sides of an acute triangle, a right triangle, or an obtuse triangle, or no triangle at all. Well, let's take a look at this first one. We know that 6 squared plus 9 squared blank 12 squared. We get 36 plus 81 and 144. We know that the 144 is greater than the sum of AB, so this would be obtuse. Because A squared plus B squared is less than C squared, it's obtuse. Let's take a look at B. 3.2 squared is 10.24. 4.2 squared is 17.64. And 5.2 squared is 27.04. I know that this side is greater than this side, so it would be an acute triangle. In this one, notice that the larger number is given first. Doesn't matter. We know that the largest number has to be the C, so I'm going to go square root of 13 squared plus square root of 25 squared and square root of 38 squared. I get 13 plus 25 is equal to 38, so that is a right triangle. And if we look at this last one, I know that if the two smallest sides do not add up to greater than the third side, that it is not a triangle. For 28, what is the length of the diagonal of a square with side length 7? Well, we would say 7 squared plus 7 squared equals C squared. I get 49 plus 49 equals C squared. I get the square of 98, square root gives me 7 square roots of 2. It's also the 45-45-90 ratio of 1 square root 2. For 29, if we want to find the perimeter of this triangle, we need to, in exact form, we're going to have to get all of the side lengths. We know that since it's a 30, 60, 90 right triangle, the ratio of the sides are in a 1 square root 3 2 ratio. So the hypotenuse of this is twice as much as the short leg, so we'll call that 14. We know the long leg of this triangle would have to be 7 square roots of 3, or the square root of 3 times whatever the short leg is. So the perimeter of this thing would be 7 plus 14 is 21, plus 7 square roots of 3. For this one, we're trying to find the sine, cosine, and tangent of A. We know that we're going to use SOHCAHTOA to find that. The sine of A is the opposite over the hypotenuse. So the opposite of A is over here at 7. The hypotenuse is 25. The cosine of A is the adjacent over the hypotenuse, And the tangent of A is the opposite over the adjacent, 7 over 24. 31. The side length of an equilateral triangle is 12, which would make this bottom cut into two parts, 6 and 6. We know since it's an equilateral triangle that this is a 60-degree angle. That's a right angle, which makes this one up here 30. So if I wanted to find this altitude here, we would take 6 times the square root of 3 because it's a 30, 60, 90 right triangle, which are in the ratio 1 square root 3, 2. For question 32, we know Euler's formula, faces plus vertices equal edges plus 2, to find the number of vertices on a polyhedron with 14 faces, and those 14 faces are 8 regular hexagons. Well, 8 hexagons, a hexagon has 6 edges, so 8 hexagons would have 48 edges. And 8 squares. Squares have 4 sides, so 24 edges. We get 72 edges total. But in a polyhedron, each of those edges is shared by 2 shapes, so we're going to divide that by 2. And so I get 36 edges. So if we have 14 faces, we're finding vertices. We have 36 edges. So we get 38 on this side of the equation, 14 plus v on this side. Solving, I get the number of vertices has to be 24. So if we're driving up a hill with a 12% grade, and we drive 12 miles, what's the horizontal distance to the nearest tenth of a kilometer? Well, we're going to have to use a trig function here. Adjacent and hypotenuse means we're using the cosine of 12 degrees is equal to x over 12. Solving that, I get 12 times the cosine of 12. Doing this on my calculator, I get x equals 11.7 kilometers. If we're going to find the nearest degree, we know we're going to use the inverse functions. This is the hypotenuse, this is the adjacent. So we're going to use the inverse cosine of x is going to be equal to 9 over 16. Putting this into my calculator, well, the inverse cosine of both sides, and I get to the nearest degree 56 degrees. Inverse cosine of 9/16. A segment with endpoints on a circle is going to be a chord. A tangent looks like that. A radius looks like that. And a secant looks like that. A chord starts on the circle and ends on the circle.